Hello everybody, today we're doing another math video and for Algebra 1 and today we're doing the part 2 of Unit 2, not part 1 of Unit 2, which is modeling data with linear and exponential functions. You might remember that we did representing linear and exponential functions, now we're modeling that data. So before we were using the data that was given to us, in which it was kind of like a straight line, almost like this, just like a straight line. But this one, whoops, we're doing data points that are all over the place. Here, just everywhere. But either way, I'm gonna click that. So, continuing on, we are doing eyeballing the line of best fit, in which we will line of best fit. Whoops. You may not have known the line of best fit, but it kind of goes with the scatter plot. But if you don't know the line of best fit, it's probably good to tune in, because you will literally be almost an expert at it when you're done with the first few videos. So basically, before we can get into line of best fit, we have to get into scatter plots. Scatter plots is basically a modeled representation of a bunch of data. It doesn't have to be real life data. It just has to be just some sort of data that just goes here, and then we have an X section and a Y section. It doesn't need to necessarily say X and Y. It just needs to have an X for every Y, as you should know. What? I haven't. It's glitching out. So, basically, just think that this is what everything here says. So, the line of best fit would probably be something like this. Now, so for the line of best fit, as you could probably have guessed, the line of best fit is basically the line that best fits all the data, so that you can get a predicted score or a predicted number of something. Like if you were saying the certain shoe height, shoe size, and shoe height. So the shoe height, not the shoe height, the regular height of the human. So the shoe size is, what's happening? It's glitching out. Anyway, the shoe size will determine the height normally, and if we put all the data and find the line of best fit, we can predict if someone's shoe size was a certain number. We can predict what their height would be. But anyways, I'm getting a bit rambly. So this time we're not actually making a line of best fit. We're actually eyeballing it instead. So now we're trying to figure out something like this. So this is all the data we are given, and we are given 3 lines, A, B, and C. Now we're trying to figure out which one of these fits the line best. But if none of them are even close to it, we can say none of the lines fits the data. And I'm sorry for the glitchy mouse. Nope, didn't go away. Go away. Nope, doesn't go away. Still. But still, we can go on and we can see that this kind of like curves, and none of them is kind of like going in the middle, straight. So we can clearly see, pretty clearly, that none of the lines fit the data at all. Yay. So now, we can find another one. So, this one is really compact, and you can see that C is cutting through them evenly, and it's really close. It's really close to the actual data. Whereas A is the negative, where this is clearly a positive, or clearly a positive. Well, a very low positive, but a positive nonetheless. And this is a very strong positive, and it's cutting way past it. Only almost touching 2 lines. Well, it doesn't have to touch points. It just needs to be a good representation. So we can clearly see that C is the correct answer. In which we'll just keep doing this, but this, I'm not really sure. I'm pretty sure that instead of C, it wouldn't be C. Many of you might be thinking that because, like, oh, it's straight. Because of this curve, it don't want like it be straight. But you also have to think of the y-intercept, which we explained earlier. The y-intercept mostly would be higher because it has to balance out the data. Now that's not a good representation of what that was, so I'm going to restart that and put it somewhere else. 1, 2, 3, 4. That was not a good representation either. What? I am not good at drawing today. There we go. Now, you see that this is a better representation because it has more on one side. It has a kind of like a balanced amount on each side, because this one has 1, 2, 3, 4, 5, 6, and this one has 1, 2, 3, 4, 5, 6. This one, however, only has 1, 2 on the other side, and if you see some on like this, you just choose one side. 1, 2, and this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you see that it's not balanced, it's definitely not the number. It's definitely not the type, well, the line. So we can say none of these lines fit the data. And let me also have this. Ooh. Okay, so C, it's pretty much at the same spot. It may be a little different, but C is obviously, or not obviously, but a good representation, because it's, look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But, on the other hand, you can clearly see that half of them are on one side, and about half of them are on one side, and about half of them are on the other. So, you can see that C would be a good representation. If I'm not, it'll correct me. It's pretty much no correlation, so we got it. It's a 75%, but that's not bad. If you see a 75%, and don't feel bad. And now I will reset this so that you can see this for yourself, how it works, and basically how you can this one, you can see which one follows the line of best fit. You can eyeball it, and which one follows which line of best fit, I cannot speak today. Which line fits the data graph below. So, pause the video if you need a little bit more time, but which I'm pretty sure you don't need because this is kind of obvious, but none. So, C fits the data because it's very much clustered to C, basically, but it's not perfect, but it's not meant to be perfect because this data is not in a straight line. Now this one, we'll do another one just so you know. Now this one, it's kind of obvious, but you may get tricked. So if you need more time, and you think you have the right, if you think you have the right answer, continue watching. But if you think if you need more time, you can just pause the video right now. Because I'm starting in 3, 2, 1. Okay, so many people like to get tricked by the B and the A crossing. So it's like, maybe it's one of them. Or you may think, oh, it's B, or oh, it's A. And it's really none of them, because these are two separate lines, and they don't go anywhere near the inside. So you might think that C is also, because it crosses one of the line, and it's very well representative of the way that this graph is made. But it's not on the right y-intercept. It would probably be 2, 3, or 2.5. It's just cutting through it and right in half, like a ninja sword. But anyways, sorry for that. It would fit none of them. I'll quickly finish this. I'll quickly finish this. So this would be C. Next question. And this would be none of them. That's the first one I got 100% on. I actually did one before this to practice, and I got a 75% as well. Just like the second one. So this is the first one I actually got 100% on. So I hope you guys enjoyed the video. Hit the subscribe button. Hit the notification bell for more videos, and leave a like, because I really have, to be honest, I have no idea I kind of have no idea what I'm doing, but hey, it turned out good, didn't it? So